Right, so let us wait 1 more minute for the others. So I'm just curious, are you guys okay having a lot of seat breaks? So I think I'm the only instructor who's giving uh, 8, 6, 5 seat breaks in one module, or the others also have a lot of seat breaks.
Marami din po yung iba, sir.
Marami rin yung iba. So, kind of sure, yes. Happy Mr. Ryan. Anyway, those activities are actually super easy. So my bad on that one, since we have a lot of topics on every module. So especially on module 1, it even took us 3 days, like for 12 hours to finish everything. But in here, we're making we're doing it in a fast pace. We're making it faster than the past meetings, so that we can discuss more and more for your uh, for your benefit, of course, para mas marami kang matutunan. Anyway, so I guess most of you are here already. So any questions so far regarding with the seat break number 8?
Wala po.
All right. So here is just the representation of a matrix of reflexive property. So as you can see, we have AA, BB, CC, and then DD. So simple as that. So this one is forming a diagonal line. And then we have here the symmetric property. So this is a representation of, we have BC and then BB, and then we also have CB and then CC. Right. So this one is actually symmetric and reflexive at the same time. Right. And yeah, so that's it for symmetric and then reflexive. And then we have here matrix multiplication. So we have here the first matrix. We have the R1, 1A, 2B, 3A, and 3B. And then here's the representation of that one with a matrix. Okay. And then we have here the R2. And then here's the representation of this R2 using a matrix. All right. So the question here is, you have to multiply, or what is the product of R1 and R2? It's like R1 times R2. Okay, so here's the result, but no solution. Okay, I will show you guys the step-by-step solution later on. So here's the matrix representation of the R1, and then the matrix representation of the R2. And then here's the product of those two matrices. Right? So let's answer this one. All right. So how did we get this 1, 1, 0, 0, 1, 1, 1, 2, and then 1 from those two matrices? Okay. So first, this is the R1, and then this is the R2. Okay. So what we're trying to get here is R1 times R2 is equal to this one. Okay. So first, you have to know the sizes of each of your matrices. So question number 1, what is the size of your R1? Anyone who can read or who knows how to read the matrix sizes? So as you can see, we have 3 rows and then 2 columns. And in reading a matrix, it's always the column first by, row first, row by column. Okay, so as you can see right here, we have a 3 by 2 matrix. Okay, this is your R1. How about the R2? What is the size of your R2?
2 by 3, sir.
Pardon?
2 by 3.
2 by 3. That's correct. So we have 2 rows and then 3 columns. All right. So the next step that you need to do is verify if the column of your first matrix is equal with the row of your second matrix. Okay. So R1 is equal to R2 in terms of the in terms of the column for the R1 and then row for the R2. So if they are equal, then you can multiply R1 times R2. But if they are not equal, then you won't be able to get the product of those two matrices. Okay? Basically, those two should be equal. Wherein, yes, they are equal, then we could get the product of those two matrices. And how will you know the size of that matrix? So you will know that one by the row of your first matrix and then the column of your second matrix. So as you can see, you will have a 3 by 3 product from those two matrices. All right. So as you can see right here, we have 3 by 3, 3 rows and then 3 columns. Gets so far?
Yes, sir.
Gets.
All right, so I hope that you guys really get it. All right, next step. So how did we get this 1, 1, 0, etc., etc.? Okay, so here's how you do it. Just remove those. So this is your R2. So you have to multiply, okay, this row to this column. Okay, so basically we have their own namings. We have the A1, A2, and then we have the B1 and then B2. So it should be A1 times B1 plus A2 times B2. A1 times B1 plus A2 times B2. Okay. And then you will get this one. So as you can see, we have 1 times 1 plus 0 times 0, which is equal to 1. Gets? Are you guys able to follow?
Yes, sir.
Yes,
Yes.
sir.
Okay. So moving on. If you want to get this one, okay, so the same process, you have to multiply this row to this column. Okay, but this time it is now on the second column, not on this one. Okay, for you to be able to get this one. So 1 times 1 is 1 plus 0 times 1 is 0 is equal to 1, which is this one. All right. And for the last one, so 1 times 0, 1 times 0, row times column, rather. So 1 times 0 is 0, and then 0 times 1 is 0. So that is why you have 0 here. Gets?
Opo, sir.
All right. So I hope that you guys really were able to follow that one. And then if you want to get the second row, then you have to multiply the second row now of your first matrix. So let me just remove everything. So multiply this 1 onto the first column. So 0 times 1 is 0 plus 1 times 0 is 0 is equal to 0, which is this one. So the same with the next one. So 0 times 1 times the second column. So 0 times 1 is 0 plus 1 times 1 is 1. Okay, is equal to 1, which is now this one. And so on and so forth. Okay, so until you will reach this third row up to this third column. So were you guys able to follow on how to get a product of a two matrix?
Yes, sir.
All right. So
Yes, sir.
very good. So now let's move on to the composite relation R2O R1. So this one is super simple, super easy. So when we say R1 OR2 or R2 OR1, okay, so basically whatever is the product of that relation. So basically we have this product, right? So 1, 1, 1, 1, 2, 1. If you're going to get the R2O R1 of this one, just make the non-zero term into 1. Okay. So as you can see, the 1 still 1 since that's the replacement of non-zero. But in here, the 2 becomes 1. So like for example, if ever that this one is 25, this one is 40, this one is 100, those 25, 40, and 100 will become 1 if you're going to get the composite relation of that matrix. Okay, so you will have something like this. Okay. Just all 1 and then the others are 0. Okay, get so far? Or may nalilito? Is there someone who's confused? Diyan pa ba kayo?
Yes,
Guys,
sir.
did you guys understand this one?
Not much, sir.
Sir, medyo po.
So here's the key point, okay? Just replace each non-zero term. Okay, so regardless of the value of that term, 100, 1,000, 1,000,000, kahit trillion pa yan, just replace that one by 1. So that is why we have this 2 became 1. Right? So ganoon naman. Actually, parang bonus nga itong composite relation. Alright? So, yeah. That's it for your module 4. And then here's your last sit break. Okay? So, given R1 and R2, so find the matrix of A1 of relation R1 and then matrix of A2 of the relation R2. And then the matrix product of A1 and A2 or R1 times R2. And then the composite relation. Right? And then for number 2, so here, given R1 x y, x divides y, R1 is from x to y, R2 is equal to yz, y is less than z. Then R2 is from y to z, ordering of x, y, 2, 3, 4, 5, etc., etc. So basically in here, the relation is not yet given. So in here, you have to find the set ordered pair of relation 1 and then the set ordered pair of relation 2. Okay, and then find the matrix of the A1 and then find the matrix of the A2 and then their product and then their composite relation. So similar with this one, the relation ordered pair relations are not yet given, so you have to find their set ordered pair relations and then find the matrix A1, A2, and then A1 times A2, and then the composite relation. So yeah, that's it for the module 4. Any concerns so far or any clarification?
None, sir.
Wala po, sir.
All right. So since we don't really have enough time, okay, actually we have 4 hours of time, but I would like you guys to have the 2 hours to answer the activities that I'll be giving. Okay, so if ever that you have a questions regarding with this module, so feel free to message me on my Facebook account or Canvas. Okay, so if you guys do not have a question anymore, then you guys may now go and have a blessed evening to all of you.
Bye, sir. Thank you po.
Goodbye.
Bye, sir.
Bye, sir.
Goodbye.
Bye.
Bye, sir.
Bye, sir.
Thank you, sir.
Bye.
Sir.
Yes, Miss Maxine and Mr. Janeza, do you guys have a question?
Wala, sir.
So goodbye and see you guys next week.
Bye, sir.
Goodbye.